2020 mathematical science paper. Let P be a square matrix such that P square equal to P, then which of the following statements are true? So we have A square equal to A, where A is idempotent matrix. So A square equal to A, we can write it as A square minus A equal to 0, that is x square minus x is an annihilating polynomial. Right? Polynomial. So the minimal polynomials can be x minus, sorry, yes, one of the things x minus 1 or x comma x minus 1, right? And in either cases which has linear factors in both of them. So we can say from here that A is diagonalizable, right? So here, what are the eigenvalues? Is the two eigenvalues will be 0 and 1. So which imply that the trace of A is sum of the eigenvalues. We know from here, we already have this. Trace of A is equal to sum of eigenvalues, which is equivalent to the rank of the matrix A. This rank of the matrix is an integer. So from here it can be implied that trace of A equal to rank of A. And also rank of A is an integer, so the trace of A is also an integer. So we have the P matrix over here. So rank of P is an integer and trace of P is equal to the rank of P. So let's check with the option. So the options are trace of P is equal to rank of P and trace of P is an integer. Option 2 and 3. This is question number 72. Let A and B be n by n real matrices and C is given 2 by 2 matrix. So we have to find which of the following statements are true. First start with option 1. So lambda is an eigenvalue of A plus B. So then there exists a non-zero vector x such that A plus B x is equivalent to the lambda x. Let us consider a new vector. Okay. New vector. It is, let us take as y equal to a column vector 2n plus 1 and cy. So we will put the matrix A, B, 2 by 2 matrix. X by, put the value of y. So we have ax plus bx, bx plus ax, right? So which is nothing but both case, so it will be lambda x and lambda x. So if we take lambda out of it, so we will have the column vector of x, which is nothing but the lambda of y. So from here it is equivalent that if lambda is an eigenvalue of a plus b, then lambda is also an eigenvalue of c. So option 1 in this case is correct. It's a true statement. So let us check with option 2. If lambda is an eigenvalue of a minus b, similarly we can have a non-zero vector x such that a minus b x is equal to lambda x. So consider a new vector. So here we will consider as y equal to x minus x. So what will be the cy? It will be ax minus bx, bx minus x, right? And we can also simplify it as x minus bx minus of ax minus bx. Okay, it can be written as lambda x minus of lambda x. Take the lambda out of it, x of minus x, which is nothing but lambda y. So if lambda is an eigenvalue of a minus b, then lambda is also an eigenvalue of c. So option 2 is also correct in our case. So option 3 is lambda is an eigenvalue of a or b, then lambda is also an eigenvalue of c, right? So let us take matrix, suppose let a is 1, b is 0. So what will c will be 1 0 0 1, 2 by 2 matrix. So eigenvalues of c in our case will be 1 comma 1, whereas the eigenvalue of a is 1 and eigenvalue of b is 0, right? So 0 is an eigenvalue of b, but 0 is not an eigenvalue of c, right? So 0 is a eigenvalue of b but not c, right? So in our case the option 3 is not the correct statement. Let us check with option 4. So let us take A be a 2 by 2 matrix, 0 1 minus 1 is 0, and B be a 0 matrix. Okay, so what will be the C? We will get C as C. In C we will find, so the first row will be 0 1 0 0 minus 1 0 0 0, third row will be 0 1, and the final row will be 0 0 minus 1 comma 0. So you can identify this matrix. So this is a block diagonal matrix or diagonal block matrix, you can say. Any one of them, both are equivalent. So here the blocks of the diagonal matrices, the blocks of the diagonal are the zero matrices, and other diagonal matrices are square. So that is a block diagonal matrix. An eigenvalue for a block diagonal matrix, the eigenvalue of the diagonal blocks will be the eigenvalues of A, which is none other than lambda square plus 1 is equal to 0. So lambda is equivalent to plus minus I. Whereas the eigenvalue of C, what will be the eigenvalues of C? So it can be I, comma I, minus I, minus I. And none of them are real. So our option 4 is also incorrect. That all the eigenvalues of C are real. That is an incorrect statement. So we have only the option 1 and